And now in this lecture we'll answer on two questions. In both questions we'll find out the area of a trapezoid. In the first question we find out the area of this trapezoid, and the second question we find out the area of another trapezoid ABCD. So we start with the first question. In the drawing we have trapezoid ABCD. We know that the length of side AB is 2 units, and we also know that side BC equals to side DC, and we know that the perimeter of this trapezoid is equal to 16 units. That is to say, the sum of those four sides of trapezoid ABCD is equal to 16 units. Okay, so our mission is to find out the area of this trapezoid ABCD. So first of all, we define the length of side AD as A, and we define the length of side DC as B. And we know that DC equals to BC according to what is given in the question. So BC must be also equal to B. And the perimeter of this trapezoid ABCD is 16 units. That is to say, the sum of those four sides is 16 units. So AB plus AD plus DC plus BC is equal to 16, according to what is given in the question. So I write it down. Side AB plus side AD plus side DC plus side BC, in total the sum of those four sides of this trapezoid ABCD is 16. AB plus AD plus DC plus BC is 16. AB equals to A plus DC, that is equals to B, plus BC, that is also equals to B, plus AB. AB is 2. So in total, A plus B plus B plus 2 equals to 16. Here we subtract 2 from this equation, and you get that A plus B, that is plus 2B, equals to 16 minus 2 is 14. So here, so in total if you found out that A plus 2B equals to 14, here we subtract 2B from this equation, and you get that A equals to 14 minus 2B. So if you found out that the length of this side AD is equals to A is equals to 14 minus 2B. In the next step, we will do a construction, that is to say, from the vertex B on this trapezoid ABCD, we will draw perpendicular on BC. Again, from the vertex B, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point M. By doing this construction, we get the quadrilateral ABDM. Inside this quadrilateral ABDM, we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees, So 270 degrees plus the size of this fourth angle. In total, they must be equal to 360 degrees. According to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth angle must be equal to 90 degrees in its size. So inside quadrilateral ABDM, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this right angle if not a square. So we relate to this quadrilateral ABMD, this right angle, because it has 4 right angles. So I write it down. This is quadrilateral ABMD, this is a right angle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So, in rectangle ABDM, side AD must be equal to the opposite side BM. But AD is A, therefore the opposite side BM must be also equal to A units in its length. But A equals to 14 plus 2B. So, we can write here that BM is equal to A is equal to 14 plus 2B. Likewise, according to the same rule, in the same rectangle ABDM, side AB must be equal to the opposite side DM, but AB is 2, therefore the opposite side DM must be also equal to 2 units in its length. What is the length of this missing line segment on missing side MC? MC equals to DC minus DM. Again, MC equals to DC minus DM. So I write it down. MC equals to DC minus DM. So MC equals to DC. DC is B, according to our definition, minus DM. We just find out found out that DM equals to 2. So in total, MC equals to B minus 2 units in its length. MC equals to B minus 2 units. So in the next step, I'll copy this right triangle BMC. Then you page that we will implement the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the evaluation for Pythagoras theorem. So actually, this is the right triangle BMC that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle BMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. So I'll write it down. BC squared, that is the square of the hypotenuse, is equal to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equal to BM squared. BM is 14 minus B, therefore BM squared is 14 minus, again BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared. Plus MC squared. MC is b minus 2, therefore MC square is b minus 2 squared. So in total, we found out that b squared equals to 14 minus 2b squared plus b minus 2 squared. Here we open the brackets on this side of this equation and get that b squared equals to 14 minus 2b squared. 14 minus 2b squared equals to 14 squared, that is 196, plus 2b squared, that is 4b squared, minus 2 times 14, minus 2 times 14 times 2b is minus 56b. And we have plus b minus 2 squared. B minus 2 squared equals to b squared plus 2 squared, that is 4, minus 2 times b times 2, that is minus 4b. So here we have b squared on both sides of this equation, so b squared again cancelled. After we cancel b squared, in this side of the equation we left with nothing, that is to say 0. While on the other side of this equation we have 196 plus 4 is 200. And we have also minus 56 minus 4b is minus 60b. And finally we have also plus 4b squared. So in total we found out that zero equals to 200 minus 60b plus 4b squared. Here we divide this equation by 4 and you get that 4b squared over 4 is b squared, and we also minus 60b over 4 is minus 15b, and we have 200 over 4 is 50, and it is equals to 0 over 4 is 0. So in total we found out that b squared minus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay. So in our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is b. So x equals to b. The coefficient a equals to 1. The coefficient b equals to minus 15. And finally, the coefficient c equals to 50. So the only thing that is left to do is to put the data for our specific quadratic equation inside this general formula for x, and we find out the value of the values of b, because x equals to b. So we do it now, we get that again x equals to b, so we substitute x by b, and it is equal to minus b. b is minus 15, so minus b is minus 15, that is plus 15, plus minus square root of b squared. b is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a times c, so it is minus 4 times A is minus 4 times 1 is minus 4 times C is 50, so minus 4 times 50 is minus 200 divided by 2A. A is 1, so 2 times 1, 2A is 2 times 1, that is 2. So in total we found out that B equals to 15 plus minus. So inside the root we have 225 minus 200 is 25, and the square root of 25 is 5, divided by 2. So here we have two solutions that are possible for B. So we define the first solution is B1 and the second solution is B2. According to the first solution for B, B1 will be equal to 15 plus 5 over 2. So I write it down. The first solution for B is B1 that is equals to 15 plus 5 over 2. 15 plus 5 is 20 and 20 over 2 is 10. So the first solution for B is B1 that is equal to 10. We have also the second solution that we define as B2. The second solution is B2 equals to 15 minus 5 over 2. 15 minus 5 is 10 and 10 over 2 is 5. So the second solution for B is B2 equals to 5. Okay. And we know that AD equals to A and A equals to 14 minus 2B. Okay. So AD that is equals to A is equals to 14 minus 2B. And you know that AD is the length of trapezoid, is one side of trapezoid ABCD, therefore it is a length. AD is the length, and as a length it must be a positive number. That is to say, AD is equals to 14 minus 2B must be a positive number. So 14 minus 2B must be a positive number. That is to say, it must be greater than 0. So here we add 2B to this inequality, and we get that 14 is greater than 2B. Here we divide this inequality by 2, and we get that 14 over 2 is 7, so 7 is greater than B, or B is less than 7. B is less, or B is smaller or less than 7. So B must be less than 7. According to the first solution, B1 equals to 10. 10 is greater than 7, therefore this solution is an incorrect solution because B must be less than 7. So we cancel the solution and we're left only with the second solution that is possible for B. That is to say, B equals to 5 units in its length. So we know that a trapezoid is a quadrilateral with one pair of parallel sides. This is trapezoid ABCD. Side AB is parallel to side DC. So those two parallel sides are defined as the basis of this trapezoid ABCD. We define AB as B and DC as A. So A and B are the basis of this trapezoid ABCD. And what is the area of this trapezoid ABCD? It is equals to the sum of its two parallel bases, that is actually A plus B, times the height H over 2. The height H must create 90 degrees with two parallel bases, AB and DC. So in total, the area of this trapezoid ABCD is equal to the sum of its two parallel bases, that is a plus b, times the height edge over 2. Again, the height must create 90 degrees with the two bases. So, therefore, according to the new formula, we get that the area of this trapezoid ABCD will be equal to the sum of its two parallel bases. It is very easy to see that the two parallel bases are AB and DC. So it is AB plus DC times the height. The height must create 90 degrees with the two bases. And you can see that AD creates 90 degrees with the two parallel bases. Therefore AD is the height over 2. So in total, if we found out the area of this trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AB plus DC times the height AD over 2. We have already found out that B equals to 5 and A equals to 14 minus 2B. B is 5, so 2 times B is 2 times 5, that is 10. So in total A equals to 14 minus 2B, that is 10, and 14 minus 10 is 4. So AB equals to 4, and substitute AB by 4 plus DC. DC, in total it is 2 plus B minus 2. B is 5, so B minus 2 is 5 minus 2, that is 3. So in total DC equals to 2 plus 3, that is 5. So we substitute DC by 5 times AD. Actually, AD equals to A and A equals to 4. So actually AB is 2. AB is 2, so it is 2 times 5. Again, AB is 2, so we substitute AB by 2. We already found out that this equals to 5. And AD, we already found out that the height AD is 14 minus 10, that is 4. So the height AD is 4 divided by 2. So in total, we found out that the area of the ABCD equals to 2 times 5, that is 7. And we have 4 over 2 is 2. So in total, the area of the ABCD equals to 7 times 2, that is 14 square units. And that is the answer to the first question. Repeat again, we found out that the area of this trapezoid ABCD is equal to 14 square units. So we finish with the first question. In the next step, I present to you the second question and solve the second question of this lecture. In the second question, we have also to find out the area of this trapezoid. In the second question, we are also to find out the area of this trapezoid ABCD. This is, of course, a different trapezoid. So, in the drawing, we have trapezoid ABCD. We know that the side AD of this trapezoid ABCD equals to 2x, the side BC equals to x. In addition, we know that this is line segment AM, that is equals to 3 units in itself. This is line segment MB, this is equals to 2 units in itself. This is angle ANB, that is right angle. This is angle ADC, that is also a right angle. And finally, this is angle BCD, that is also a right angle. Again, our mission is to find out the area of this trapezoid ABCD. So first of all, we define the side of this angle BMC as alpha. So in the right angle MBC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this first BC angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. We also have rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. This is a straight line, so if we focus on the straight line DC at point M, on the upper side of the straight line DC at point M, the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the upper side of DC at point M? We have this angle that is alpha, this angle equals to 90 degrees. Therefore this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line DC at point M according to rule 3. Okay. In the next step, we'll focus on the right triangle ADM. This right triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Okay. So, it is very easy to see from the drawing that those two right triangles are similar to each other according to angle similarity rule. Well, both triangles have this angle alpha, both triangles have this is the right angle, and in both triangles we have 90 degrees minus alpha. Therefore, the triangle ADC, the big triangle ADM, is similar to this triangle, the right triangle BCM, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AD of the right triangle ADM over side MC of the right small triangle MCB is equal to side DM of the right triangle, the right big triangle ADM over side BC of the right small triangle BCM. And repeat again. From the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. That side AD of the right triangle ADM over side MC of the right triangle MCB is equal to side DM of the right triangle ADM or side BC of the right triangle BCM. And also we derive that side AM of the right triangle ACM over side BM is also equals to side AM of the right triangle ADM over side BM of the right small triangle BCM. So in total, we found out that because of the fact that those two right triangles are similar to each other, that AD over MC equals to DM over BC equals to AM over BM. AD is 2x over MC. MC is the missing side, so we leave it as it is. And it is equals to DM. DM is the missing side, so we leave it as it is. Over BC. BC is X. And it is equals to AM. AM is 3, according to what is given in the question. Over BM. BM is 2, also according to what is given in the question. So in total, we have found out that two X over MC equals to DM over X equals to 3 over 2. So those two expressions are equal to each other, so we get the equation 1 from those two expressions that are equal to each other. That is to say, according to equation 1, we get that 2x over mc equals to 3 halves. So here we will multiply this equation by mc and get that two x equals to 3 over 2 times mc. So here we will multiply this equation by 2 and then we will divide it by 3 simultaneously, and finally we get that mc equals to 2 times 2x over 3. So in total we should find out that mc equals to 2 times 2x over 3. So mc in total equals to 2 times 2x is 4x over 3. So in total we should find out that the length of line segment mc is 4x over 3. The length of this line segment mc is 4x over 3 units. Those two expressions are also equal to each other. So we get the equation 2 from those two expressions that are equal to each other. That is to say, dm over x equals to 3 halves. So I write it down according to equation 2. dm over x equals to 3 halves. Here we multiply this equation by x and finally we get that dm, the missing 97 dm, is equal to 3 halves times x. So this is the missing 97 dm, that is equal to 3 halves x. In the next step, we'll implement the Pythagoras theorem on this white small triangle BMC. So I copy this white small triangle in a new print and we'll implement the Pythagoras theorem on this white triangle BMC. Here by PT is the abbreviation for Pythagoras theorem. The hypotenuse BM equals to 2 units in its length. Side DMC equals to 4x over 3 units. And finally, BC equals to x units in its length. So actually, this is the right triangle BMC that according to the original drawing, according to the Pythagoras theorem. In this triangle BMC, BM squared, that is the square of the hypotenuse, equals to BC squared plus MC squared. So I write it down. So BM squared, that is the square of the hypotenuse, is equal to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4. And it equals to BC squared. BC is x, therefore BC squared is x squared plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So in total, we found out that 4 equals to, we have here 4x squared over 3. 4x squared over 3 is equal to 16x squared over 3 squared, that is 9. So this expression in total equals to 16 squared over 9 plus x squared. Here we multiply x squared by 9 and then we divide it by 9 in order to overcome a factor with this expression. So it is 9x squared over 9. Okay. You can multiply any expression by 1, because by multiplying any expression by 1 it will not change its value. Okay, so I shall find out that 4 equals to 9x squared plus 16x squared is 25x squared over 9. So 4 equals to 25x squared over 9. Here we multiply this equation by 9, and you get that 9 times 4 is 36, equals to 25x squared. Here we divide this equation by 25, and you get that x squared equals to 36 over 25. So here we take a root out of this equation, and finally we get that x equals to the square root of 36 over 25. The square root of 36 is 6, and the square root of 25 is 5. So in total, we have found out that x equals to 6 over 5 units in its length. Our mission is to find out the area of this trapezoid ABCD. According to the formula that I presented to you, the area of any trapezoid is equal to the sum of its two parallel bases, that is actually AD plus BC, times the height. The height is AD because of the fact that AD, the height is the sum of its the two parallel bases are BC and AD. And the sum of the two parallel bases is BC plus AD. Okay? The two parallel bases are BC and AD, and the sum of those two parallel bases is BC plus AD, and the height is DC. Why the height is DC? Because of the fact that DC creates 90 degrees with the two parallel bases. So, in total, the area of this trapezoid ABCD is equal to the sum of its two parallel bases. AD is parallel to BC. The sum of those two parallel bases is AD plus BC times the height, that is DC, over 2. And again, there are trapezoid ABCD equals to the sum of its two parallel bases, that is actually AD plus BC times the height, that is DC, over 2. AD is 2x plus BC, BC is x, times the height DC. Again, AD is 2x and BC is x times DC. DC in total equals to dm plus mc, that is to say, DC equals to dm, that is 3x over 2, plus mc, that is 4x over 3. So in total, DC equals to 3x over 2 plus 4x over 3, all divided by 2. So in total, if we found out that the area of trapezoid ABCD equals to 2x plus x times 3x over 2 plus 4x over 3 divided by 2. 2x plus x is 3x. So we have 3x over 2. We have here, inside the brackets, we have 3x over 2 plus 4x over 3. So here we take 6 as a common factor out of those two expressions. That is to say, we will multiply the numerator of this expression by 3 and also multiply the denominator of this expression by 3. 3x times 3 is 9x, and 2 times 3 is 6. We multiply this expression, the numerator of this expression by 3, and then we divide it by 3. It is like to multiply it by 1. We didn't change the value of this expression. So after multiplied by 3 and divided by 3, found out that this expression equals to 9x over 6. Likewise, we multiply this expression by 2, and then we multiply the numerator of this expression by 2, and then we will divide it by 2. Or either you can say that we multiply the numerator by 2 and the denominator by 2. So 4x times 2 is 8x, divided by 2 times 3, that is 6. So in total, we found out that the area of trapezoid ABCD equals to 3x over 2. Inside the brackets, we have 9x plus 8x is 17x, divided by 6. So here we will divide both the numerator and the denominator of this expression by 3. 3x over 3 is x. So in total, in the numerator we left only with x times 17x. In the numerator we left with 6 over 3 is 2 times 2. We have 2 again here. So in total, if we found out that the area of trapezoid ABCD equals to 17x times x is 17x squared, over 2 times 2 is 4. We already found out that x equals to 6 over 5, 6 fifths. So we substitute x by 6 fifths, and get that the area of trapezoid ABCD in total equals to 17 over 4 times x squared is x times x. X is 6 over 5 times x is 6 over 5 again. So here we have 6 times 6 is 36, and 36 over 4 is 9. Again, 6 times 6 is 36, and 36 over 4 is 9. So in total, we have only 17 times 9 over 5 times 5, that is 25. 17 times 9 is 153 divided by 25. 153 over 25 is 6.12 square units. That is the answer to the question. So if you found out that the area of this trapezoid ABCD is equal to either 153 over 25 square units, or in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. So we finish with the second question. In the next step, I will summarize the lecture. We'll start with the first question, of course. In the first question, our mission is to find out the area of this trapezoid ABCD. It is given us the question that side AB equals to 2 units in its length, side BC equals to side DC, and we also know that those two angles are right angles. Again, our mission is to find out the area of this trapezoid ABCD. First of all, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. ABCD is a quadrilateral because it has 4 sides, and because of the fact that side AB is parallel to the opposite side DC, it is defined as a trapezoid. Again, a trapezoid is a quadrilateral with one pair of parallel sides. Those two parallel sides are defined as the bases of this trapezoid ABCD. We define the area of the base AB as B, and define the area of the base DC as A. So the sum, what is the area of this trapezoid ABCD? Is equal to the sum of its two parallel bases times the height edge over 2. So the sum of its two parallel bases is of course A plus B times the height edge over 2. The height edge must create 90 degrees with the two parallel bases. So the area of this trapezoid ABCD is equal to the sum of its two parallel bases, that is actually A plus B, times the height edge over 2. Okay. So in the first step, we define the length of side AD as A, we define the length of this side DC as B. And because of the fact that BC equals to CD according to what is given as the question, and DC equals to B, therefore BC must be also equal to B. And the most important thing that is given as the question is that the perimeter of this trapezoid ABCD is equal to 16 units. That is to say, the sum of those sides, 4 sides, that is to say, side AB plus side AD plus DC plus side DC plus side BC, the sum of those 4 sides of this trapezoid ABCD is equal to 16 units in total. So here AB plus DC, AB plus AD plus DC plus CB equals to 16 units according to what is given as the question, because the perimeter of this trapezoid ABCD is 16. So the sum of those 4 sides of trapezoid ABCD is 16. That is actually the perimeter of this trapezoid ABCD. Again, the sum of the 4 sides is AB plus AD plus DC plus BC. That is 16 according to what is given as the question. AB is A, DC is B, and BC is B, and AB is 2, AD is A, DC is B, and BC is also B. And again, AB is A, AD is B, DC is B, and BC is 2. And this equals to 16. So in total, we should find out that A plus B plus 2 equals to 16. A plus B is 2B. We subtract 2 from this equation. We find out that A plus 2B equals to 16 minus 2 is 14. So A plus 2B equals to 14. We subtract 2B from this equation. And finally found out that A equals to 14 minus 2B. A equals to 14 minus 2B. Side AD is equals to A according to our definition is equals to 14 minus 2B units in its length. So we have here, in the next step, we did a construction, that is to say, from the vertex B, this trapezoid ABCD, we draw perpendicular on DC. Again, from the vertex B of this trapezoid ABCD, we draw perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in DC. This point is point M. By doing this construction, we can do quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. Those 2 angles are right angles according to what is given as the question. This angle is right angle according to our construction, so in total we have here 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4th angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this 4th angle must be equal to 90 degrees in its size. So inside quadrilateral, the small quadrilateral ADMB, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So related to this quadrilateral ABMD is a rectangle because it has 4 right angles. Okay. But we know that the opposite sides of a rectangle are equal to each other. So a rectangle ABMD, side AD must be equal to the opposite side BM. But AD equals to A, that is 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B. Likewise, according to the sum rule, in the sum rectangle AB DM, side AB must be equal to the opposite side DM, but AB is 2 according to what is given as the equation, therefore the opposite side DM must be also equal to 2 units in its length. What is the length of this missing side line segment MC? From the drawing it is very easy to see that MC equals to DC minus DM. Again, MC equals to DC minus DM. So MC equals to DC, DC is B according to our definition, minus DM. We just right now found out that DM is 2, so we sum the DM by 2. So in total, MC equals to B minus 2 units in its length. In the next step, I copied this right triangle BMC in a new page and implemented the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, this is the right triangle BMC that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle BMC, BC squared, it is the square of the hypotenuse, equals to BM squared plus MC squared. BC is B, therefore C squared is B squared, it is equals to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared, plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, we found out that B squared equals to 14 minus 2B squared plus B minus 2 squared. Here we open the brackets on this side of this equation, and finally we found out that B squared equals to 14 minus 2B squared. 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared, that is 4B squared, minus 2 times 14 minus 2B, that is minus 56B, plus B minus 2 squared. B minus 2 squared equals to B squared, plus 2 squared, that is 4, minus 2 times B times 2, that is minus 4B. Here we have B squared on both sides of this equation, so B squared get cancelled. After we cancel B squared, on the side of the equation we left with nothing, that is to say 0. While on the other side of the equation we have 196 plus 4 is 200. We have also minus 56 minus 4b is minus 60b plus 4b squared. So in total we found out that 0 equals to 200 minus 60b plus 4b squared. Here we divided this equation by 4. And finally found out that this 4b squared over 4 is b squared. Minus 60b over 4 is minus 15b. And 200 over 4 is 50. So in total, we found out that b squared minus 15b plus 50 equals to 0. This is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is b, of course. So x equals to b, the coefficient a equals to 1, the coefficient b equals to minus 15, and the coefficient c equals to c. So the only thing that is left to do is to put this data inside this general formula in order to find out the value of the values of b, because x equals to b. So we did it. So x equals to b, so we substitute x by b, and it is equals to minus b. B is minus 15, so minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a times c. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4, times c is 50, minus 4 times 50 is minus 200. So in total, inside the root we have 225 minus 200, that is 25, and the square root of 25 is 5. So in total, we found out that b equals to 15 plus minus 5 over 2. So here we have two solutions that are possible for b. So we define the first solution for b as b1, and the second solution for b is b2. The first solution for b, that is b1, b1 equals to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b is b1 equals to 10, while according to the second solution, that is b2, b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So we found out that b2 equals to 5. So AD is one side of trapezoid ABCD. And you know that AD equals to A, that equals to 14 on to B. AD equals to A, and A equals to 14 minus 2B. AD is a side of trapezoid ABCD, it is a length, and as a length it must be a positive number. That is to say, the length of AB, that is 14 minus 2b, must be positive. What is a positive? It means that it must be greater than 0. So we added 2b to this inequality, and finally found out that 14 is greater than 2b. Here we divided this inequality by 2, and finally found out that b is less than 7. So b must be less than 7 units. So the solution that b is 10, that is greater than 7 units, is incorrect solution. So we cancel this solution, and we left only with the second solution that is possible for b, that is actually b equals to 5. Okay, so if b equals to 5, it means that a equals to 14 minus 2b. b is 5, so 2 times b is 2 times 5, that is 10, and 14 minus 10 is 4. So a equals to 4 units. A is the height, it equals to 4 units. Here we have b minus 2, that is 5 minus 2, that is 3. And we know that according to what is given as the question, AB equals to 2. So the area of trapezoid ABCD is equal to the sum of its two parallel bases times the height over 2. Okay. Repeat again, the area of trapezoid ABCD is equal to the sum of its two parallel bases times the height over 2. Repeat again, the area of trapezoid ABCD equals to the sum of its two parallel bases. That is actually the two parallel bases are AB and DC. So it is AB plus DC. The sum of the two parallel bases is AB plus DC times the height. The height is AD. The height is AD because of the fact that it creates 90 degrees with the two parallel bases. So the height is AD divided by 2. AB is 2 according to what is given in the question, plus DC. DC in total it is 2 plus 3, this is 5. This is 5 times the height. We already found out that the height AD is 4. So we substitute AD by 4 divided by 2. 2 plus 5 is 7. So in total this expression equals to 7 times 4 over 2. 4 over 2 is 2. So in total this expression equals to 7 times 2, that is 14 square units. So if we found out that the area of this trapezoid ABCD, that is the area that we are looking for in this question, is equal to 14 square units. So finish with the first question. In the next step, I presented to you the second question, and we solve the second question of this lecture. That we also to find out the area of a trapezoid. It is of course a different trapezoid. In this lecture, in this second question, our mission is to find out the area of this trapezoid ABCD. We know that side AD equals to 2x, side BC equals to x. This is a right angle, and those two angles are also right angles. And again, our mission is to find out the area of this trapezoid ABCD. Okay, so first of all, we define this angle BMC as alpha. So in the right angle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. And 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line DC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DC at point M? We have this angle that is alpha plus this angle that is 90 degrees plus this missing angle. In total they must be equal to 180 degrees according to rule 3. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles of the upper side of DC at point M according to rule 3. So, in the right triangle ADC, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, therefore this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. It is very easy to see that those two right angles are similar to each other according to angle similarity rule. In both triangles we have angle alpha, in both triangles we have this angle, this is the right angle, and in both triangles we have this angle that is 90 degrees minus alpha. Therefore, those two right triangles, that is to say triangle ADM and this triangle BMC, are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AD of the triangle ADM over side MC of the right small triangle MCB is equal to side DM of the right big triangle ADM over side BC of the small right triangle BCM, and it is also equal to side AM of the big right triangle AMC of the big right triangle AMD over side PM of the small right triangle BCM. And again, we derive that AD over MC equals to DM over BC equals to AM over BM. AD is 2x, MC is the missing side, so unlimited cities. DM is the missing side, so unlimited cities, and BC is x. And it is equals to AM. AM is 3 according to what is given in the equation over BM. BM is 2 according to what is given in the equation. So those two expressions are equal to each other. So we can get the equation 1 from those two expressions that are equal to each other. So according to equation 1, 2x over MC equals to 3 halves. Here we multiply this equation by MC and found out that 2x equals to 3 halves MC. Here we multiplied this equation by 2 and then we divided by 3 simultaneously and found out that MC equals to 2 times 2x over 3. 2 times 2x is 4x, so in total this expression equals to 4x over 3. So in total we found out that MC equals to 4x over 3. This is 97 MC, that is equals to 4x over 3. Those two expressions are also equal to each other, so we get the equation 2 from those two expressions that are equal to each other. According to equation 2, dm over x equals to 3 halves. dm over x equals to 3 halves. Here we multiply this equation by x and finally found out that dm equals to 3 halves times x. dm equals to 3 over 2 times x. So this is dm, this is equals to 3 over 2 times x. Okay. So in the next step, we implemented the Pythagoras theorem on this right triangle BMC. So for this right triangle BMC in an equation, we implemented the Pythagoras theorem on this right triangle. This is the right triangle BMC that I copied from original drawing. According to the Pythagoras theorem, in this right triangle BMC, BM squared, that is the square of the hypotenuse, is equal to BC squared plus MC squared. Again, BM squared equals to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4, and it is equals to BC squared. BC is x, therefore BC squared is x squared, plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So 4 equals to, here we multiplied x squared by 9 and then we divided by 9 in order to have a common factor with this expression. So it is 9x squared over 9. That is of course equals to x squared. So 4x over 3 squared is 4x squared, that is 16, x squared over 3 squared, that is 9. So in total we found out that 9 and that 4 equals to 9x squared over 9 plus 16x squared over 9. So 4 equals to 9x squared plus 16x squared is 25x squared over 9. Here we multiply this equation by 9 and finally found out that 25x squared equals to 9 times 4 is 36. So 25x squared equals to 36. Here we divided this equation by 25 and finally found out that x squared equals to 36 over 25. Here we took a root out of this equation and finally found out that x equals to the square root of 36 is 6 and the square root of 25 is 5. So in total x equals to 6 fifths. X equals to 6 fifths. Okay. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? The area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually AD plus BC times the IDC over 2. The IDC creates 90 degrees with the two other bases. But again, there are this trapezoid ABCD equals to the sum of its two parallel bases, that is actually AD plus BC times the height DC over 2. There are trapezoid ABCD equals to the sum of its two parallel bases, that is actually AD plus BC times the height, that is DC over 2. AD is 2x, BC is x. Again, AD is 2x and BC is x times the height DC. DC in total is equal to 3 over 2 times x plus 4x over 3. So DC in total equals to 3x over 2 plus 4x over 3 divided by 2. 2x plus x is 3x, and we have here, it took 6 as a common factor out of those two expressions. That is to say, if we multiplied this expression by 3 and then we divide it by 3. 3x times 3 is 9x and 2 times 3 is 6. Likewise, we multiply this expression by 2 and then we divide it by 2. So it is 4x times 2, that is 8x, and 3 times 2 is 6. So in total, we should find out that thereafter this trapezoid ABCD equals to 3x over 2 times 9x plus 8x over 3. 9x plus 8x is 17x divided by 6. So in total, the trapezoid ABCD equals to 3x over 2 times 17x over 6. So here we divided both the numerator and the denominator of this expression by 3. 3x over 3 is x, so in total in the numerator we have x times 17x, and we have here 6 over 3 is 2. So we have here 2, another 2, so it is 2 times 2. So in total there of this trapezoid ABCD equals to x times 17x over 2 times 2. 2 times 2 is 4. So in total, the area of trapezoid ABCD must be equal to x times 17x is 17x squared over 4. So in total, the area of trapezoid ABCD equals to 17x squared over 4. So it is 17 over 4 x squared. X squared is x times x. And we already found out that x equals to 6/5. So x equals to x square is x times x, so it is 6/5 times 6/5. So in total, thereafter, ABCD equals to 17 over 4 times 6/5 times 6/5. We have here 6 times 6 is 36, and 36 over 4 is 9. So we cancel those three numbers, and in total they are equal to 9. So in total we have 17 times 9 over 5 times 5, that is 25. 17 times 9 is 153, so in total this expression equals to 153 over 25. So in total, we should find out that the area of this trapezoid ABCD, that is the area that we are looking for this equation, is equal to either 153 over 25 square units. In terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. Okay, thank you very much.